Welcome to Broad Eye, the podcast that explores knowledge gaps in ophthalmology and eye care. Hello, everyone, and welcome to another episode of the Broad Eye podcast. My name is Sean Maloney, and I'm here today with my good friend and co-host, Dr. Bruno Fernandez. Bruno, how are you doing today?
I'm doing good today, Sean. Thanks for asking.
Good. I know you're very excited about our guest today. We were talking before she joined us, so we're going to dive right into it. Our guest is Dr. Laura Thaler. She is a lecturer at Durham University in the Department of Psychology, and we know her best as an echolocation expert researcher. So, Laura, thanks for joining us today.
My pleasure. Thanks for inviting me.
That's our pleasure. So we're going to have some fun. So, in our previous conversation a few weeks back, you were telling me a little bit about your background and how you got into echolocation research. And I was hoping maybe you could share that journey with us, with the audience. What did that look like, from starting out in academics and finding yourself as an echolocation researcher?
Yes. So when I was working on my PhD, I was very interested in how we use vision to perceive the space around us and how we use vision to guide movements of our hands. And when I was then, nearing sort of the completion of my PhD, I was interested in how the brain deals with all of this. So I wanted to do some neuroimaging. And I got in touch with Mel Goodale, who was at Western Canada, then at Western University. And so I went there after my PhD, and we started devising some research. And then, as it so happened, Mel got a message from Gordon Dutton, who is a neuro-ophthalmologist in Glasgow in Scotland. And he mentioned Daniel Kish and, pointed out what he does and that he uses clicks to echolocate. And we then Googled it and were just astounded actually at the amount of information that was available just by Googling it. That was back in 2009. And we were immediately hooked. So I just was fascinated, and it was very new for me. Echolocation uses sound, but what struck me was just how confident and versatile, and how, going through all of these things that were available on the web at the time, it was just amazing how great this worked in a lots of different scenarios. You get clips with Daniel riding his bike and doing all sorts of things. And we just wanted to tap into this and just do some research on it, and mainly also learning how the brain deals with this information. And yeah.
Yeah, this is so exciting. Like, I don't even know how to start. I have so many questions. Like, when I started doing some research, like before having news, I guess, on our podcast, I was humbled on like how little I know about all that. And I understand the visual pathways pretty well, but I was surprised to see that in echolocation, the same visual primary cortex is stimulated. So I was just wondering if you could explain, like, to me in our audience, like, how does it work? Because they hear the echo, but that somehow goes towards the part of the brain that processes like light stimulus.
Yes. So in when the visual system is so let's say if there's no visual input coming in through the retina, then the whole brain adjusts, lots of things happen. And it has been previous research investigating then how our brain areas may be taken over. Now, echolocation works through sound, so the sound enters through the ears and then goes along auditory pathways. And then during neuroimaging, what we found was, however, that when we compared, which parts of the brain respond to these echoes and which parts of the brain respond to sound that's sort of the same, but basically just lacks the echo. So that was our control sound. And comparing these two conditions, we found that one part that was really processing or very active when these echoes were present was primary visual cortex, which typically processes light in people who are normally sighted. And So, that was just really amazing to us, because even though other research had shown that the brain reorganizes itself and that in people who are blind, visual cortex can process, for example, touch or sound, primary visual cortex is still somewhat special, because it's the earliest entry point for visual radiations on the cortical level. So it's that's still very exciting to see that something as tiny as an echo elicits activity in that part of the brain. How that exactly works, actually, we still don't know. But at some level, there must be the information that's obtained from the echoes must be either be channeled directly into that part of the brain. There are some direct connections between early auditory cortex and early visual cortex. It's also possible maybe that this gets channeled through other higher order areas. So a bit like, they go into these higher order areas and then come projected down into maybe primary visual cortex. So the exact way it works, we don't know yet.
And how far it goes the potential of humans to be fully dependable on echolocation? Like, can someone be trained like to as a bat, for example, like that doesn't need to see at all and can just fly around and avoid anything? Can humans be that able to rely on echolocation? Do we have that potential?
Well, bats actually, many bats use vision as well. What people say, blind as a bat, that's actually not a good phrase, because many bats have visual processing and they have vision and they do use it as well. So echolocation and vision can be complementary. And what we actually find in our work is that everyone can learn to echolocate. And that means people who have no vision at all, people who are totally blind, but also people who have some residual vision, and also people normally sighted. Everyone picks it up. And, there are different levels to which people can come. Like some people may become much more proficient than others. Sometimes hard to pinpoint exactly what the reasons might be for this. One thing that's very obvious to us is that people who are blind use echolocation much more. It's just more useful to them.
So, Bruno is asking the question about the potential that people have in terms of echolocation. And you're mentioning that people can, pretty much anybody can learn this. I'm just curious what that looks like. If I came to you and said, Laura, okay, I have visual impairment and I'd like to learn to echolocate. Is this like something that is going to take me years to learn the basics, or is it something you can pick up the basics quickly? And maybe what would that look like, I guess, if I came to you and said, help me learn how to echolocate?
Yeah, so the basics you can pick up almost in an instant. I'd say maybe 10 minutes tops. It's and this surprises many people, but the key is that all you need to do is you need to find a sound, a situation that's just really obvious. So I call it like the hook stimulus. You have to find something where the echo is just very obvious to the person that's trying to learn it. What I like to do, for example, if someone comes, says, teach me, the first thing is that I demonstrate just a bit how these clicks work. I encourage them to make their own clicks. And then we bring in simple objects like a large book, a tablet, or a salad bowl. I have various salad bowls in the office. And then you can bring these in front of the person, and it's usually very obvious when that object is in front of you. And some people can hear that even without making any clicks themselves. And if that's the case, you can just move it a bit further away. And, at some point, you'll probably find a distance at which, without clicking, the person won't be able to hear it. And then you encourage them to make a click, and then you just, bring it in front, take it away. And usually they can tune in relatively quickly. You just have to make sure that, you're very clear in what it is you're doing, so that the person trying it out doesn't feel like, this is all very random. So they have some way of linking the experience of what they're hearing to what happens to the object that's being presented.
I just have a quick note on that. So, when you and I spoke previously as well, I had mentioned that being visually impaired, I had done some orientation and mobility training, and I was never taught to echolocate in that sense of producing sounds, and maybe we can come back to that. But just the minute you completely take away vision, you naturally get a little bit more in tune to your environment, right? And I distinctly remember two scenarios. One where I'm walking with a blindfold. I have a guide making sure I don't run into things. But as I was walking down a hallway, it might have been 12 or 15 feet wide, a pretty large hallway. I could tell the minute I was walking past an open door, even if there was no sounds coming from the room, I could tell I was walking past an open door, or if the concrete wall, if I was passing by a window, for example. And it was pretty amazing, without any training at all, how I noticed those types of things in my environment. Or if you go into a space with the ceilings, the height changes from a 10-foot ceiling to a 30-foot ceiling or something. And another thing that I remembered was when, and maybe this is echolocation, maybe it's not, I don't know, but when my guide was telling me, okay, let's just walk along and just tell me what you notice. And I got to a point where I just stopped suddenly. And she says, well, why did you stop? I said, I don't know. I just felt like I was going to hit something. And she says, take off your blindfold. And I was maybe 18 inches away from a wall. She was prepared to stop me, but it was almost like this pressure I could feel on my body as I was approaching something. I don't know. Is that echolocation also, or is that something else?
No, absolutely. I mean, echolocation is, it's a broad term. So echolocation in the really broadest sense is just you use reflections of sound to get information about your environment. And, that can be you relying on the sound that's already around you without making any additional sound. And so that's the experience that you're describing is actually, I think that's very representative. There's a lot of sound in the environment and does give you a lot of information because the sound bounces around everywhere. And as you approach corners or gaps, it changes, and that is echolocation. We call that passive echolocation. And the echolocation that we investigate in our research is active echolocation, so where people make their own sounds, and in particular mouth clicks. But it doesn't have to be mouth clicks, can also be other sounds, could be finger snaps, could be whistling, humming, people may use a clicker. It's all this similar principle. And when we investigate this click-based echolocation, it's actually what we always do is we compare how do people go about a task, or how does their brain process things when the clicks and echoes are present as compared to when they're not present. And what's important is that in this control condition, all the other sounds are still there. So any benefits that we, for example, then report or find are those that are just really that you get by making the clicks and processing the click echoes. And that's just for us to isolate this process, because active echolocation, same principle in a way as passive echolocation, only difference, you make your own sound. And then the benefit is that you just have control over what's happening. You can decide when to make your sound, where to put it, do you click to the right, to the left, straight ahead. And also if everything's totally silent, you just have this additional thing. I like to refer to it as the acoustic flashlight.
And for active echolocation, you mentioned that it can be clicks or it can be any type of sound. Is it just a personal preference, or is there a sound that it's better than the other, generates a more accurate echo?
Yes. One thing that we've noticed in our research is that people who use active echolocation by themselves, they all know how to use the clicks, and many discover them spontaneously for themselves. The clicks are easy to make. I'll just make one. I'm not sure how this will actually sound, but I'll just give it a go here. You hear that?
Yeah.
Yeah. So they're quite brief sounds. They're actually very loud, but because they're very brief, they don't sound very loud. It means, however, that the sound can travel quite far and you get a good echo back, even though it's not super loud. If you made the same loudness of sound, say doing a whistle or a voice, would be very noticeable, very loud. Another advantage is that you can make the clicks without breathing, which means if you're walking or doing something, it doesn't take away your breath.
Mm.
And they're fairly reproducible as well. Research has shown that one advantage of active echolocation is that if you have a sound that's fairly reproducible in terms of spectral content, and so because the clicks, the way you make them, they're actually quite reproducible. That is maybe one reason also why we think that people find them quite useful.
And are there companies looking into developing devices like to help echolocation, either by producing those clicks in a very like standard and reproducible way, or let's say like a hearing aid that it's placed on the ear and augment the perception of those echoes?
Mm-hmm. There have been quite a few patents, I think even going back to like the 50s, where people have proposed or developed devices based on this echolocation principle. None of these devices have really had a big breakthrough, and maybe it's possible that they were just not as intuitive perhaps as the natural echolocation process, or maybe, you know, there's a price to consider. There are things to consider such as, you know, maintenance, reliance on batteries, things such as this. Many devices that I am aware of and have read about, they extract certain features from the environment, like the distance of something. And when you do your own clicks and interpret them, actually, you can decide which feature you want to listen to, right? You can determine how far away something, but we know that echolocators can also get information like shape, if something's moving or not, the material that it's made of, the position, also if it's like behind you. So that's maybe one of the reasons why perhaps at this point none of the devices haven't been as successful perhaps as natural echolocation. But that said, it's not like there are lots of people who use click-based echolocation at the moment, but we do find that it's picking up the more people learn about it.
I'm thinking that maybe, and this is just a hypothesis, but maybe why there's not a ton of people with low vision that are using click-based echolocation is because the first impression might be that, oh my goodness, this is tough. Like right when you mentioned Daniel Gish and there's other people who have seem to have mastered this type of skill, and it's, you know, even when I look at that, I say, wow, you know, hey, that's amazing, and that's just, you know, obviously they have some sort of genetic predisposition to being superheroes, and I could never learn that, or if I did, it's going to take, you know, 20,000 hours or whatever. Maybe you know, as people become more familiar with the domain, they can realize that a certain level of proficiency could be achieved actually rather quickly, and not, you know, it doesn't require this, you know, thousands of hours of mastery. I was hoping that you could maybe comment on conscious versus unconscious effort in terms of echolocation.
Let me actually first go back to what you said before about the amount of effort required and the skill level and so on, because actually earlier I had mentioned, but then we sort of went off with something else. So it certainly requires practice, but for example, we've run a research study where people took part in a 10-week training program. They came twice a week and did 2 hours twice a week, and all of them came out with skills that they use in their daily life and which they reported as being super helpful, and had a very positive impact on their mobility and independence. You know, that's not thousands of hours, but I totally agree with you. You know, not everyone's going to be like Daniel Kish or like some of the other echolocators who you might find featured in the media, but that might be also just because people have different personalities. You know, not everyone wants to ride a bike, not everyone wants to go mountain climbing. Sometimes the reports that are in the media may raise some unrealistic expectations about what echolocation can do. Sometimes it is described as seeing with sound, which then, you know, leads people to believe, oh yeah, this is like I can see now. But it's different because it's based on sound, and there are certain limitations that come with it, but also certain advantages. So for example, I mentioned earlier, the clicks are a bit like an acoustic flashlight, or, you know, whichever sound you decide to make, but that means it's sort of is like a point elimination. So it doesn't give you everything. And also, you know, sometimes things will block it where it goes. One thing that we know is that echolocation is not very useful at detecting things at ground level. So none of the echolocators that I know would use it without, for example, something like the long cane or a guide dog. All of the echolocators use these other mobility tools as well. Many of them will use additional things, you know, also GPS or other electronic or apps that are available. So echolocation is a skill that anyone can learn and that can be useful, and that certainly can help orienting on, for example, detecting targets at further distances, like up to 50 meters away or so that can be useful for orientation. And it can also help you detect if something's coming up and is about to maybe hit you in the face, so then you can just stop. But it's not going to be like a, you know, a super tool. Yeah.
Like for vision, so there is this condition in ophthalmology called amblyopia, that if a vision doesn't get stimulated in an early age, so let's say a kid that has a cataract, after like 7 years of age or something, even if you correct like that the cause for the temporary blindness, the vision is not restored. So basically the brain cannot process visual stimulus anymore. For sighted people, you know, like they never relied on echolocation that much, does the same thing happen? Like, do we, let's say me, I'm 40 something, is it too late for me to work on it? Do you have more success when you train young people than older people due to the plasticity of their brains?
Our research, so we have addressed this question actually of age, how does age affect it? But the our age range was, so the youngest participant was 20 and the oldest one was 79. And we did not find a relationship between the age of the person and the degree to which they learn to use echolocation. So it seemed that the older participants learned just as well as the younger ones.
And so, as we're talking about participants, just as a curiosity here, how hard or easy it is for you to recruit like people to participate on those studies? Because people are usually reluctant, like to be guinea pigs, but I would be so pumped, like to be to be a participant of a study like this.
Yeah, we typically don't have any problems in terms of finding participants. People are happy to take part. The logistically most challenging study we did was the 10-week study where people had to come in twice a week. And even there, actually, we did find, you know, we had people who wanted to come in. One problem we had, or we sometimes encounter, is that for some of the research that we've done to date, we had quite strict criteria about the level of vision that people could have had. So for example, the recent training study was for people who were either totally blind or just had bright light perception. And, you know, then the limits we had that we hit where we are here in Durham in the UK was really more geographical problem. Because, you know, if you have to do this sort of thing, you don't want to drive an hour each time.
Yeah.
So, you know, I wasn't just maybe before we wrap up, I want to circle back to your research a little bit, and we can dive into this for a while if you have the time. Your research in echolocation, I think there's probably not, you know, thousands of groups around the world doing this, but it seems that what you're, from my understanding of the research, just briefly looking through what you've done, is that it informs the general learning community, I guess, about how the brain is learning. Am I, you know, off in left field on that, or is that something that you're taking out of this too, or that the whole field is taking out of this, that it's not just about echolocation, that there's more coming out of the research that you're doing that has broad applications?
Yes, no, you're exactly right. So we use echolocation because, you know, we're fascinated by it, because there's a direct use for people who have vision impairments, but we also use it as a paradigm to investigate on a more general level, how does the brain learn stuff? And now the beauty using click-based echolocation for this is that many people, or the majority of people at this point at least, have little to no experience with it. And so that means that when we start out people with this, we have a nice baseline. So for example, when I was mentioning the effects, or that we had people participating who were younger and older, you know, none of them really reported to have experience in click-based echolocation before that. And so that means that when we start them, there's, you know, we can be reasonably confident that with respect to this particular skill, everyone starts from scratch. And then when we track progress, it just, it does give us more confidence, or gives us good confidence that we can then investigate how this affects the brain, and that the changes that we observe aren't, say, contaminated, if you will, is maybe a bad word, but anyway, that we have a good way to investigate then how the brain changes in response to learning new skills in general. And echolocation is just our paradigm that we choose to do this.
As we are, I mean, on that, like this echolocation ability being used by like sighted individuals, has anyone ever used that to let's say improve their performance? Like I'm thinking about an athlete that like becomes more able, and that gives him an edge like over his opponent.
It's actually, you know, it's funny you should ask. So one thing that we are investigating, and I do this with collaborators here at Durham, for example, Marco Nardini. And one thing that we look at is how do people integrate information across various sensory modalities. And we have, for example, investigated how people may combine information that they gain from vision and from click-based echolocation. And what we do find is that people they combine information from both, and in instances where vision is not very good, people's performance improves by adding in information that they gain from echolocation, and this is the case for people who are normally sighted.
That's very
cool. So Bruno, I know where that question is coming from. So
yeah, exactly.
I think Laura, I don't know how much you know Bruno's background as an ophthalmologist, but he's also a world champion in Brazilian Jiu-Jitsu. And
and a coach now, so
a coach now. He's
like to train some superhumans.
Yeah, no, but it's funny you said, because you know, I know I've trained with him before too, and they'll actually do classes sometimes completely in the dark to help train the athletes in that way, to say, okay, it helps them just instead of trying to depend on their eyes when they're in close combat. Yeah,
I think so there's that element, right? You shake up your common belief on how things are by taking away something, and then people get more acute. They tune in more into the other senses. So if you take away vision, they might tune more into audition, into touch, also temperature or smell, all of these elements. When you learn a new skill, that could be click-based echolocation, but also just learning a new language, your whole brain usually also reshuffles itself, and research has shown that it can actually lead to generalized cognitive benefits. So for example, learning a new language might give you a better ability to focus also in other tasks that have nothing to do with that new language. And we think, but we haven't done the research yet, that's something that we are, you know, in the process of doing, that when you learn a new skill like click-based echolocation, that might also give you generalized benefits in, for example, the ability to focus in other domains. So there's sort of a benefit from learning a new skill, and, you know, possibly click-based echolocation, which might sort of transcend just being better in that particular skill, but it might just give you another general sort of boost, if you will.
No, and that's definitely interesting. So I just wanted to circle back to one question that I was asking, and then I asked two questions in one, and didn't really give the opportunity. But I had asked about conscious versus unconscious effort, and I was hoping maybe you can touch on that and explain what that means.
Yeah. So when people learn, or when they first start off, you making the clicks and, you know, getting into echolocation, most of them have to concentrate a lot. So they do will tell us, I find that I have to concentrate. And so this would certainly be a conscious effort. But then when I'm out and about with people who've used click-based echolocation for a long time, they sometimes do these like very rapid adjustments, like avoiding a branch that's hanging down or a small pole or something where, and I'm not used so used that they will do this. I just go, but then they still do this very quickly. So, and these responses or reactions and motor movement, they just seem so quick and so swift that it seems almost automatic or unconscious. And so I think there's an element of how long one has been doing this, to the degree to which this then requires, a lot of effort, or to which degree it might become automatic. It's something that we haven't done a lot of research on. One study that we have currently under review is that we asked people who were sighted and learned to echolocate, that we gave them another task to do, like a digit span task. And it seemed that this didn't really affect their ability to echolocate very much. So it seemed that those almost went in parallel. But when they had to do a task where they had to when they have like a competing visual stimulus, for example, that seemed to affect their performance. So I think in some degree, maybe echolocation could be considered conscious. Unconscious is a bit difficult because it depends maybe how you define it, but there are certainly levels at which people are able to do another task whilst they're also echolocating, or they may respond in a way that seems very fast and automatic.
Before we wrap up, I would just like to say that at some point in time, maybe when COVID is a distant memory, and Bruno and I find ourselves on the other side of the pond, I would love to go to your lab and learn how to to echolocate. I would love to do a podcast. Like, it's okay. This is real, echolocation raw. Like, just learning and kind of walk through some of that, because I think it's something that is extremely interesting to the audience, not just for patients that might be listening, but just for clinicians and researchers too, to understand that. So hopefully, if that opportunity presents itself, that you'll take us on as temporary subjects.
No, absolutely. I'd be pleased to. I tell you what, we are actually also, what I would like is developing resources where people could actually do this remotely online. The remote experience is not ever going to be the same as a real person experience. I think there's also an element when you train echolocation and you have someone with you who's good at it. You sort of, it's inspiring. So it's a bit, there's that element that you don't get from learning this remotely and on your own. But then at the same time, there are definitely elements that people could learn by themselves, and they don't have to come, to my lab. I mean, many people wouldn't be able to do that. One thing that's happening right now actually in the UK is that, because we've also been informing a lot and we've met a lot with rehab workers, with rehabilitation workers and so on, there's really a growing sense of that this is something that's really useful to do. In many ways, it's not super novel. I mean, if you go back in the literature, the first time, someone reported from this use of echolocation with sounds is in 1700 something. So it's really not terribly new. I think the new angle is that it's now sort of very systematic, and that we're honing in on this particular active echolocation using clicks or brief transient sounds, and that we have this additional tool of neuroimaging where we can track how this affects the brain. And I think all of this together maybe helps raising awareness and maybe also gives it a bit more credibility.
No, then this is great. I'm going to guess that whenever you're applying for grants, you don't say this is from the 1700s. We've known this for hundreds of years. They say, well, then why are we funding this? So no, that's fantastic. Listen, this has been fun. I'm hoping that we can maybe get you back on the podcast at some point in time. Maybe that's with the live echolocation training with Bruno and I, identifying salad bowls and everything else that goes along in the lab. Like, maybe we can do a challenge or something. That'd be really fun to see how fast we could learn. But but listen, this is fantastic, and we're going to link out to some of your research, if you don't mind, through the podcast website for people who want to learn more about what you're doing and where the field's at. And yeah, I'd just like to take the opportunity to thank you for joining us today. It's certainly been a pleasure speaking with you.
Thank you. Thank you very much. Yeah, I enjoyed this very much as well.
Thank you, Laura.
Thank you.
And that concludes today's episode of the Broad Eye Podcast. If you enjoyed this episode, please be sure to subscribe on your favorite podcast platform. Of course, ratings and reviews are always welcome. And you can certainly share this episode with any of your colleagues or friends who might enjoy it. Thanks for listening.